Hey everyone, it's Justin again. In this lesson, we're going to learn how to simplify rational expressions. Let's get into it. We have two objectives for this lesson. First, by the end, you should be able to find values for which an expression is undefined. Also, you should be able to simplify both factored and unfactored rational expressions. First, we'll define what a rational expression is. Then we'll complete 3 practice problems that were already factored for us. Finally, we'll complete one more practice problem where we'll have to do the factoring. So what are rational expressions? We can define a rational expression as the ratio of 2 polynomials. Rational expressions can look like this, with a trinomial in the numerator and the denominator. They may look like this, with a constant in the numerator and a binomial in the denominator. Even this is considered a rational expression. It just has a lot of variables. For this lesson, we're only going to be focusing on expressions with one variable, though. So now that we know what a rational expression is, let's try some examples. Our first example says to find the values for which the rational expression is undefined and simplify the expression. All right, first we want to find where this expression is undefined. But what does that mean? A function is undefined if the denominator equals 0. Can't divide by 0, right? So we look at the denominator and see that there are 3 factors all multiplying together. If any of these factors equals 0, that would make the expression undefined, because that alone would turn the denominator into 0. So if x equals 0, then this expression would be undefined, along with x equaling 7 and x equaling 2. So we'll make sure that it's clear that x cannot equal 0, 7, or 2. Now let's move on to simplifying the expression. There have to be common factors in the numerator and the denominator in order to simplify it. We see x minus 7 in both the numerator and the denominator, so those 2 factors cancel each other out. Now we have our simplified expression. Our next example says to find the values for which this rational expression is undefined and then simplify it. First, we want to find where this expression is undefined, so we look at the denominator and see that there are 2 factors. If either of these equals 0, the expression is undefined. So if x equals 4, this expression would be undefined. Or if x equals 5 over 2. So we make sure it's clear that x cannot equal 4 and x cannot equal 5 halves. Now let's move on to simplifying the expression. There have to be common factors in the numerator and the denominator in order to simplify. We see that 4 minus x can become x minus 4 if we factor out a negative sign. Then the x minus 4s will cancel each other out. Now we have our simplified expression. Also, as a little side note, it's more common to move the negative symbol outside of the denominator. So if you notice something like this, just move the negative to the front. Also, since there's only one factor in the numerator now, we can take off the parentheses. The same thing is true with the denominator. Next example says to find the values for which the rational expression is undefined and simplify it. Why don't you pause the video here and try this problem by yourself? First things first, we want to find where this expression is undefined. There are 3 factors in the denominator. So if x equals 0, if x equals negative 2/3, or if x equals 7 halves, this expression would be undefined. So along the side, we write that x cannot equal those numbers. Now let's move on to simplifying the expression. There have to be common factors in the numerator and the denominator to simplify, so we see that negative 3x minus 2 can become 3x plus 2 if we factor out negative 1. Then 3x plus 2 will cancel in the numerator and the denominator, and we have our simplified expression. We can also move the negative to the front and get rid of a set of parentheses. All right. Now we are moving on to a tougher example. This example has the same directions, but this time the expression isn't factored for us. So let's begin by factoring the numerator and the denominator, and then we can work through this problem the same way we did in the previous examples. We factor the numerator by finding two numbers that multiply to be negative 10 and add to equal negative 3. Negative 5 and 2 fulfill those requirements. So we use those numbers to factor. Now let's factor the denominator. We can factor x out of all three of the terms. From there, we figure out what two numbers multiply to be 6 and add to be 5. Those numbers are 2 and 3. So this gives us our factored denominator. Now we just do exactly what we did in previous problems. So pause the video now and try to finish the problem from here. There are 3 factors in the denominator. We set each of them equal to 0 and get that x cannot be 0, negative 2, or negative 3. Now we simplify. We cancel the common factors in the numerator and the denominator. Now we have our simplified form. Now you can simplify rational expressions. We know how to determine undefined values and factor when it isn't already done for us. See you next time. Hey.